Tanse, I'm Dallas Wapash, an Inanu Soto video game designer. This is the second part of a 4-video series that will introduce you to the Unity game engine and the process that goes into making your first game. By the end, we're looking to have a video game with a character we can move, objects that we can collect, and a video game to beat. This series is part of a larger initiative from Taking It Global and Imaginative. This initiative is hashtag Create2Learn that teaches youth digital skills. To learn more about their upcoming projects, check out their Instagram at Create2Learn or the hashtag Create2Learn on social media. Before we continue, a land acknowledgement. This series was produced in Brandon, Manitoba on Treaty 2 territory, the traditional lands of the Cree, Oji-Cree, Anishinaabe, Dakota, and Dene peoples, and is the homeland of the Métis Nation. This treaty was made in 1871, and to learn more about where you come from, visit trcm.ca. Alright, so in this part, we're going to get our level made, a character moving and jumping. While doing so, there's a lot of things that we can learn about Unity with references, bools, if statements, and layer masks. When I run my game, my character doesn't move. My Napaduck has no physics. So I'm going to add a component, a rigid body. To review, I do this by selecting my Napaduck game object in the scene hierarchy, and within the Inspector tab, I click on Add Component. Okay, so let's go back to our code. I need to reference both my Capsule Collider 2D and Rigid Body 2D components. I do this by going to the top of my public class. Remember to stay inside its curly brackets, as we want to stay inside of its scope. I'll show you two different approaches to referencing components, each with their own benefits. The first approach is with a public reference. A public reference is one that involves using the Unity engine in some capacity, as opposed to just Visual Studio, or the software you're coding with. I'll write public, then the name of the component that I want to reference. In this case, a Capsule Collider 2D. If you used a different collider for your character, you'll have to write that name here. Next, I need to give this component a code name. It would be super exhausting to have to write Capsule Collider 2D every time in my code, so instead, I give it the shorter code name call, which is a lot faster to type in the long run. I'll do the same for my Rigid Body 2D, but instead use private at the start, and give the code name RB. Private references are established using only Visual Studio. Remember to use your semicolons at the end of the lines. So call is written in black, but RB is grayed out. Why is that? The reason for this is because call will need Unity to click and drag the component inside the engine, while RB will need code to get the component. The engine understands the context for both. Since that code doesn't exist for the collider yet, it's grayed out because it thinks we're doing something pointless. We're not referencing our component at this point. So when I go back to Unity, it refreshes after a couple seconds, and a section was added to my script. I'll click and drag the Capsule Collider 2D component onto this new section. Now that reference is made, but there's no option to drag my Rigid Body 2D. For that, we gotta use code. We want this reference to be made at the first frame of our game, or else things won't work, so we'll have to use the start function. First, we'll start off by using our code name RB. We need to specify that RB equals the result of something. Unity has a command called getComponent. We'll use triangular brackets to specify what type of component we're looking for, in this case, the Rigid Body 2D. Outside these triangular brackets, we need empty braces, as this is a function, and then we add a semicolon. Cool, we made that reference. Since the command is just getComponent, the script will search for something attached to the game object as the script. Now, I want to make it so that when I press on the spacebar on my keyboard, something happens. To do this, we use if statements. Basically, they're written like if something happens, and that something is specified by these braces, then we make something happen within a set of curly braces. Using the spacebar is considered an input, so I'll Google Unity input. From that, I see that Unity has input.getKeyDown, and it shows me an example of how to write a command. So I'm going to copy and paste that into my own code. Then I'm going to change what it does to my own function to suit my needs. Let's start again. Whoops, the rigid body made my Napaduck fall, but the code works. Whenever I press on the spacebar, the function does its HOA thing from earlier. Now, let's make a level out of tiles. You can think of this as something like Minecraft, where levels are made out of individual cubes. I made a square picture of a tile and followed the same steps as my star blanket to make sure it wasn't blurry. It was super small, so I changed its pixels per unit and took off the filter in the Inspector tab. Then I sized down my Napaduck using the R keyboard shortcut, because they were very large. To create a grid for your tiles, right-click in the scene hierarchy, hover over 2D objects, and click on Tile Map. This will create a grid with a tile map child inside of it. We need to create a new window to work with. Head to Window at the top of the screen, hover over 2D, and then Tile Palette. This creates a new window that I can click and drag wherever I want. FYI, you can arrange all of these windows however you want, and so I want my tile palette to partner with my scene hierarchy. In the Tile Palette tab, I need to create a new palette. I'll click on Create New Palette, give it a name, click Create, and make a new folder for it by right-clicking and choosing New Folder. I'll give this folder a name and save. Then I find my tile image and drag it into this new palette that I've made. A window will pop up so that I can name my tile. I'll just click Save to save some time. Then my tile shows up in my Tile Palette window. I see that all these tools that I have access to, I'm really just concerned with the brush, so I make sure the brush is selected. Then I click on my smiley tile and begin to paint within my scene window. Alrighty, so take some time to paint whatever level you want. Huzzah! I've painted my level and it's fairly small. Okay, so two issues right now. My camera is zoomed away and my character falls through the level. The reason my character falls is because my level doesn't have a collider. So I need to find my tile map game object, select it, and add a component to it. The name for this component is Tile Map Collider. By adding it, I can vaguely see that my tiles are given green squares around them, just like the green capsule my character has. So bam! It works, but my game is still zoomed out. So I'll stop that for now and go to my main camera game object. Check out its projection size in the inspector, and yeah, that's a bit too big, so I'm going to make that number smaller. Okay, so we've made a Game of the Year contender. We just need to get our character moving now. First, we need to consider that characters move according to a speed, and that we'll want to tweak that speed for game feel. For that, we'll want to use a number, and numbers are stored within things called floats. So let's type in public float speed. Public because we want to be able to change this within Unity, and then float for the info type. And then we give it a code name of speed. Remember how update is called every single frame rendered in the game? Well, this can cause problems for movement, since we'd be basing our gameplay off of frame rate, which would vary from computer to computer. So to solve this, we'll use something called void fixed update, which is different in that it's called at a fixed rate. So fixed update is based more on time than frames. We're going to create a new variable called horizinput, an abbreviation of horizontal input, and make it so that it equals our input on an axis. For left and right movement, we want that axis to be the horizontal plane. And Unity has a framework for this already, so we'll just write it as such. Input.getAxis, and inside braces, quotation marks, horizontal. So at this point, we're only tracking input. We're not actually making something happen based on it. At this moment, we know that rigid body 2D component causes our character to fall. Based on that, we'll have to command the rigid body 2D to move in ways that we actually want. I believe this will be the hardest part of the whole series, but we got this. By Googling Unity Rigid Body 2D, we can find its scripting API, and guess which one might work for us. So through trial and error, we find that velocity is what we're looking for. Velocity influences what direction our character moves, so clicking on it in the API shows us the next step. This command involves a vector 2. Vector 2s are a representation of two different values, an x horizontal value and a y vertical value. Since this movement is based on our input, which could vary every frame while we play, we want it to be new every time. So this is a new vector 2. For our x-axis, we want it to be based off of our input multiplied by speed. So we'll write horizinput multiplied by our speed. And since we only want to move left and right, we'll leave the x-axis to whatever it is at that given moment, because we're also going to be jumping later. I was getting errors because I forgot to add public float hors input at the top, so make sure to add that. Let's save with Ctrl and S and let Unity refresh. Then we'll have to set a number for our character's speed and run our game. Now, in 2D games like this, usually the character faces in the direction they're walking. Currently, my Napedic just faces the right. There are various approaches to this, and one I found was online that used a function. Let's create a boolean. Bools are used to say true or false, on or off, 0 or 1. The source I'm referencing called their bool facing right, but any name could work. We'll set this to true, since by default our character is facing right. Then let's write a function that alters the bool. Type void flip, remember our braces and curly brackets, and to capitalize. This function will make it so that we switch our boolean and invert our character's size so that we're facing the other way. So, facing right equals the opposite of itself, as established by this exclamation point. It's great to write it this way, as this function will be called whether we're right or left and just toggles what we are in that given moment. Then, we create a reference to our character's scale. Since there are 3 values here, an x horizontal, y vertical, and z depth, we'll use a vector 3 with the code name scalar. We'll want to make it so that it is equal to our game object's transform's local scale. We'll then reference only our x scale and invert it. Then we'll set the entire scale to this inverse number. This basically means that in all of the directions that our character can be stretched, we stretch them inside out to face the other way. Now, we gotta know when to flip the character. We don't want to flip them every time we press a button, otherwise they'll flip to the opposite direction they're moving in by accident. For this, we'll create another if statement. If facing right is equal to false, so if we're facing left and our input is greater than 0, which means we're moving right, then we'll flip. I type 2 equal signs here to say equals, and type 2 ampersigns to say, and this too. So both of these requirements must be met. So we're saying if we're facing left but moving right, then flip. We'll need to do the same for the other side, so else if we are facing right but moving left, then flip. By pressing play, we can see that our character moves appropriately from left to right. Awesome, they can see where they're going. The great thing about this method is that by inversing our scale, our children get flipped too. So our character rolls left and right. I think it's cute, but it could cause problems when we get our character jumping, so let's go to the rigid body component and freeze our rotation in the inspector. Now let's get jumping. We don't want our character to have infinite jumps or else the game would become too easy. The game needs to know if we are on the ground or not, and to do that, we need something to detect the ground. We'll create a bool to check if we're on the ground, and name it something like on ground. We're going to create a small circle by our character's feet to detect a ground layer. This ground layer will be specified by us so that not everything qualifies as ground. Otherwise, everything would reset our jumps. We're going to make a public transform reference, the click and drag, and name it ground checker. This is where our invisible circle is going to be located. Then we'll give it a range based on a float and call it checker size. Then we'll create a public layer mask reference with the code name ground stuff. A layer mask is used to separate game objects, and this will be super helpful so that we can specify what actually qualifies as ground. Now, in our fixed update, we're going to check our bool for on ground. We'll set it to the result of physics 2D. using the period to access this class and find overlap circle. This overlap circle checks to see if our ground checker circle is overlapping with the ground. Overlap circle needs the position of our ground check transform. We'll use the period to access that. Then overlap circle can also take a radius, which we have. So we'll type a comma and place it there, and then another comma to place our ground stuff layer. So back in Unity, we must create an empty game object and rename it to ground checker. In the Inspector tab, there is a cube there after we've made this object. This is called a gizmo, and is what our game object looks like in the scene view. Clicking on it will allow us to change it. We'll place ground checker by my Napaduk's feet, and set it to a child of my Napaduk, so that this checker moves with it at all times. So, because we made all of our values public, we can see them in the engine. Let's click and drag our ground checker where it needs to go. Set our radius to 1 or something like that, and now we need to make a new layer mask. In the inspector, at the top, we see tag and layer. So select layer, and then we see a whole bunch of layers, but we need to add another one. So we'll go to add layer, because we don't have that one specified yet. Once you do that, type in something like ground stuff. Game objects can have layers, like an ogre, but we want our grid of tiles to be that layer. So we'll find the tile map with the collider and set its layer to ground stuff. So this is great, but our character still isn't jumping. Let's go back to Visual Studio. Remember how floats are used to hold numbers? Well, there's another method, one that allows for whole numbers like 1 or 2 instead of 1.5 or something like that. This is called an integer, or int for short. Let's make that reference with the code name jumps left, and then we'll also need a float to establish how high we want to jump. We'll call it jforce for jump force. Update is a helpful function for tracking inputs because players can still press buttons between every rendered frame. In there, we'll create an if statement for our spacebar and put 2 ampersands to place a secondary condition. If the person presses spacebar and has more than 0 jumps left, we'll add velocity to our rigid body that sends us up. Multiplied by our jump force. Now all we need to do is subtract our jumps left, since at this point we've made our character jump. This is done with 2 subtract symbols, but if we kept subtracting, soon we wouldn't have any jumps left, so we need to reset this when we land on the ground. Before this check, we'll create another if statement. If we're on the ground, set jumps left to 2. You can change this number depending on how often you want to jump, but for me, I'll save, go back to Unity, and make sure you have a value set for your jump force, along with a layer mask set for your ground tiles. I forgot to do this, so it was giving me trouble at the start. And so now, we have a jumping character. Awesome! So next time, we'll take a look at making collectible objects, and it won't be as technical as this part, so look forward to that bit of a break from code. I'm not Alice, I'm Dallas with a D, and we'll see you then!